Welcome to physics scenario classes. Dear students, today I am going to discuss a question of electrodynamics that was asked in GATE 2010. The question states, two magnetic dipoles of magnitude m each are placed in a plane as shown in the figure. Here dipole 1 is placed and dipole 2 is placed here. Each have magnitude m. This is 45 degree. Here it is also 45 degree. And the separation between the two dipoles is d. The energy of interaction is given by option A 0, option B mu naught m square upon 4 pi d cube, option C 3 mu naught m square upon 2 pi d cube, and option D minus 3 mu naught m square upon 8 pi d cube. In order to solve the question, here we fix a frame of reference. This is x-axis, this is y-axis, and this is the origin. So the coordinates of point A is, it is 0 in x direction and it is d upon root 2 below from the origin in y direction. So its coordinates is 0 and minus d upon root 2. Coordinates of point B is d upon root 2 in x direction and 0 in y direction, so it is d upon root 2 and 0. The position vector of dipole 2 with respect to dipole 1 is vector r. Here we have written vector r. So vector r is vector AB, and that is vector AO plus vector OB, and vector AO is minus of vector OA plus vector OB. Here it is minus, and vector OA is what? This is in y coordinate minus d upon root 2 j hat, plus OB, it is in x coordinate, so it is d upon root 2 I hat. So vector r is d upon root 2 taking common I hat plus j hat. Now the interaction energy between the two magnetic dipoles vector m1 and vector m2 separated by a displacement vector r is given by u equals mu naught upon 4 pi 1 upon r cube under bracket dot product of vector m1 and vector m2 minus 3 multiplied by vector m1 dot r hat again multiplied by vector m2 dot r hat. Here we need r hat, so let us find r hat. It is vector r upon mod of vector r. So this is d upon root 2 I hat plus j hat divided by mod of vector r. This is d, so it is I hat plus j hat upon root 2. Now vector m1 dot r hat, it is m1 vector m1 mj, because it is oriented in y direction, so it is mj hat, and this dipole is oriented in x direction, so it is vector m2 equals m I hat. M represents its magnitude, I hat its direction. So it is mj hat dot I hat plus j hat upon root 2. So the result is here j, so it is m upon root 2, because j dot j equals 1. Now vector m2 dot r hat, it is mi dot r hat, it is I plus j hat upon root 2, and then I coordinates will combine, so it is m upon root 2. Now vector m1 dot vector m2, it is mj dot mi hat equals 0. Why? Because both are mutually perpendicular. This is in direction, this is in direction, so they are making 90 degree. So the interaction energy is u equals mu naught upon 4 pi 1 upon r is replaced by d, because mod of r is d here given, 1 upon d cube, and now substituting these values we find m1 dot m2, that is 0 minus 3 m1 dot r m upon root 2, again vector m2 dot r, it is m upon root 2. So by simplifying this we get minus 3 mu naught upon 8 pi m square upon d cube. Thank you.